Hi, Dr. Catherine here from ChemPraxis. Today we are going to discuss Chemistry, Paper 6, Alternative to Practical, 0620/62, February-March 2024 paper. For question 1, calcium carbonate is an insoluble solid. Calcium carbonate can be made by adding excess aqueous calcium chloride to aqueous sodium carbonate. This is the chemical equation. A student makes a sample of calcium carbonate. The first two steps of the method are shown in figure 1.1. So for step 1, the students add excess aqueous calcium chloride to aqueous sodium carbonate. This is aqueous calcium chloride and this is aqueous sodium carbonate. And then step 2, the students stir the mixture. For question A, name the item of apparatus labeled A in figure 1.1. You can name it as a glass rod or you can name it as a stirring rod. And for question 2, suggest why the mixture is stirred in step 2. For stirring purpose, we usually want to evenly distribute the components throughout the mixture. For question C, after step 2, the student filter the mixture to remove the solid calcium carbonate form and collect the filtrate. Draw a label diagram to show the apparatus used for this filtration. So you need to draw a filter funnel, and then you also need to draw a filter paper. This is a must. Don't forget to draw filter paper. And you need to draw a conical flask. This is the conical flask. And then for this question, basically you need to show the apparatus only. So if let's say you forget to show that the residue is a solid, which is the calcium carbonate, and you forget to label the filtrate, which is sodium chloride, it's fine. Because for this question, you just need the apparatus. As long as you draw filter paper, filter funnel, and conical flask, and you label it, you will get your 2 marks. For question D, the solid calcium carbonate obtained by filtration is not pure. Identify one substance other than water which is mixed with the calcium carbonate and makes it impure. It is the sodium chloride, because when you let the calcium chloride react with sodium carbonate, they will form calcium carbonate and sodium chloride. So for this residue, they may have some sodium chloride that attach to it. Yeah, maybe on the surface of the calcium carbonate you have some sodium chloride, and this one will be the sodium chloride. So for question Roman 2, describe how the substance you have identified in D1 can be removed from the calcium carbonate. You can wash the residue with distilled water to remove sodium chloride. For question E, describe a test the student can do on the filtrate obtained in C to show that the calcium chloride used is in excess. Give the result the student obtains if the calcium chloride is in excess. In this case, you need to use sodium hydroxide. First of all, you can add few drops of sodium hydroxide. After that, you can add in excess, because for calcium ions, they will form white PPT. So you can detect the presence of calcium ion by using NaOH. And let's say if you are trying to answer the question by using silver nitrate, this is not recommended because for the filtrate, they contain chloride. So if you use silver nitrate, you will get white PPT, which they will react with the chloride ion as well in the filtrate. But since you want to show that this one contains excess calcium chloride, you need to plan an experiment targets calcium ion. For question 2, a student investigates the reaction between aqueous sodium carbonate and 2 different solutions of dilute hydrochloric acid, labeled A and B. The student does 3 experiments. For experiment 1, rinse a burette with distilled water and then with dilute hydrochloric acid A. Rinse a conical flask with distilled water. Fill the burette with dilute hydrochloric acid A. Run some of the dilute hydrochloric acid out of the burette so that the level of the dilute hydrochloric acid is on the burette scale. Record the initial burette reading. use a measuring cylinder to pour 25 cm³ of aqueous sodium carbonate into the conical flask. Add 5 drops of methyl orange indicator to the conical flask. Stand the conical flask on a white towel. Slowly add dilute hydrochloric acid A from the burette to the conical flask while swirling the flask until the solution becomes orange. Record the final burette reading. For experiment 2, refill the burette with dilute hydrochloric acid A. Run some of the dilute hydrochloric acid out of the burette so that the level of the dilute hydrochloric acid is on the burette scale. Record the initial burette reading. Empty the conical flask and rinse it with distilled water. Use the measuring cylinder to pour 25 cm³ of aqueous sodium carbonate into the conical flask. Add 5 drops of timolphthalein indicator to the conical flask. Stand the conical flask on a white towel. Slowly add dilute hydrochloric acid A from the burette to the conical flask while swirling the flask until the solution becomes colorless. Record the final burette reading. While for experiment 3, repeat experiment 1 using dilute hydrochloric acid B instead of dilute hydrochloric acid A. For the next question, use the burette diagrams in figure 2.1, 2.2 and 2.3 to record the readings for experiments 1, 2 and 3 in table 2.1 and complete table 2.1. So for experiment 1, the initial reading is 0.8 and the final reading is 26.2. We have record the values here and here. And then after that for experiment 2, this is 0.2 and this is 12.9, 0.2 and 12.9. While for experiment 3, this is 1 and this one is 39.1. So 1 and 39.1. An important note for reading recording, you need to make sure that they have the same decimal place. If not, we will deduct 1 mark. And also, after that, you need to calculate the volume of dilute hydrochloric acid added. You can use the final burette reading to deduct the initial burette reading to get the volume. For question B1, state which solutions of dilute hydrochloric acid A or B is the more concentrated. Explain your answer. The more concentrated solution of dilute hydrochloric acid will be A because it is more concentrated. Hence, lower volume of HCl is needed to neutralize sodium carbonate solution. For question 2B2, deduce how many times more concentrated these solutions of dilute hydrochloric acid is than the other solutions of dilute hydrochloric acid. If you compare the volume, which is 25.4 and also 38.1, the ratio basically is 1 to 1.5 times. So, which means the hydrochloric acid A is 1.5 times more concentrated than hydrochloric acid B. For question C1, compare the volume of dilute hydrochloric acid A used in experiment 1 to the volume of dilute hydrochloric acid A used in experiment 2. The volume of HClA used in experiment 1 is 2 times the volume of HClA used in experiment 2, as you can see from the volume that we calculated. Deduce the volume of dilute hydrochloric acid B required to reach the endpoint if experiment 3 is repeated using timolphthalein indicator instead of methyl orange indicator. Use your answer to C1 to help you. Since we know that for experiment 1 and experiment 2, we are using the same hydrochloric acid, but one is methyl orange indicator and the other one is timolphthalein indicator, we can use this as a reference. So if let's say this is 38.1, we can divide this value by 2 in order to get the volume of HClB that we need to use to change the color of timolphthalein. So we can put this value for our answer. For question D, at the start of experiment 3, the burette is rinsed with distilled water and then with dilute hydrochloric acid B. Identify the substance removed from the burette when it is rinsed with distilled water at the start of experiment 3. The burette before that is used for experiment 1 and experiment 2. But in terms of experiment 2, before that, the burette is used to store HClA. So if we want to use it for experiment 3, And HClB, we need to rinse the burette to remove this. For question Roman 2, describe how the result of the titration would change if the burette was not rinsed with dilute hydrochloric acid B after it had been rinsed with water. Because burette is used to store hydrochloric acid B and used for titration, if you rinse the burette with distilled water, but you do not rinse the burette with hydrochloric acid B, some of the distilled water will remain in the burette. And when this distilled water remain in the burette, when you add hydrochloric acid B, you will affect the titration volume. And in this case, higher volumes of hydrochloric acid B is needed, and the result will not be that accurate. For question Roman 3, explain why the conical flask is not rinsed with aqueous sodium carbonate after it is rinsed with water. Because for sodium carbonate, it is the solutions that we transfer to the conical flask. Let's say if you rinse with sodium carbonate and you do not dry the conical flask properly, you may have the sodium carbonate in extra volume. Put it this way, extra volume. And if you have extra volume, we will have higher titration volume. So for this question, you can say that to avoid introducing sodium carbonate solution, that could change the titration volume. So now we discuss question E. Explain why a white towel is used during the titration. If you use a white towel, it is easier for you to observe the color change of the indicator. For question F, describe the effect on the result of warming the aqueous sodium carbonate used in experiment 1 before carrying out the titration. Explain your answer. There will be no effect because the concentration of HCl and sodium carbonate, they are still the same, so they still remain unchanged. Now we are going to discuss question 3. A student tests two substances, solid C and solid D. Test on solid C. Solid C is ammonium iodide. The student dissolves solid C in water to form solution C. The students divides solution C into 3 approximately equal portions. Complete the expected observation. For question A, to the first portion of solution C, the students add about 1 cm³ of dilute nitric acid followed by a few drops of aqueous barium nitrate. Barium nitrate, particularly barium, they are used to test sulfate ions. So if sulfate ions is not present in this case, there will be no reactions. For question B, to the second portions of solution C, the student adds about 1 cm³ of dilute nitric acid followed by a few drops of aqueous silver nitrate. So for silver nitrate, we are using this to test the halide ion. Because iodide is present in solution C, they will give you a yellow precipitate. For question C, to the third portions of solution C, the student adds an excess of aqueous sodium hydroxide. While for the first Roman 1, the observation we will put no change. But for Roman 2, when the students warms the product from C1 and test any gas given off, they will have gas release, and this gas will turn the damp red litmus paper to blue color. For information, when you have ammonium ion and when you let it react with hydroxide ion, they will form ammonia gas and water. And we call this as base displacement. The stronger base displace the weaker base. So when ammonia gas produced, they will change the red litmus paper to blue. For the test on solid D, table 3.1 shows the test and the results observation for solid D. When you do a flame test, they give you a yellow color flame. So for yellow color flame, usually They means that they have sodium ions in solid D. While for test 2, gently heat about half of the remaining solid D, hold a strip of anhydrous cobalt 2 chloride paper at the mouth of the boiling tube. Steam is given off and condensation forms at the top of the boiling tube. When steam is given off, it actually gives us the idea that this is an hydrated salt, and steam basically is water. So when you test water vapor or water with the anhydrous cobalt 2 chloride, the paper will change from blue to pink. While for test 3, dissolve the remaining solid D in water to form solution D. Divide solution D into 3 portions. To the first portion of solution D, add aqueous ammonia dropwise until in excess. And there's a green PPT which is insoluble in excess. So if let's say this is a green PPT, which means it is Fe2 plus because Fe2 plus is green in color. While for test 4, to the second portion of solution D, add a piece of aluminium foil and about 5 cm³ of aqueous sodium hydroxide. Because ammonia and sodium hydroxide, both of them, they are used for cation tests. So the green precipitate is formed, which shows you that this is Fe2 plus. And when you heat the mixture form and hold damp red litmus paper at the mouth of the boiling tube, the red litmus paper remains red. So for information, aluminium foil and sodium hydroxide, they are used to test the presence of nitrate ion. So if there is no nitrate ion, no ammonia gas release, the red litmus paper, they will remain red. For test 5, to the third portions of solution D, add about 5 cm³ of dilute nitric acid. Bubble any gas formed through lime water. There is effluences and the lime water become milky, means that carbon dioxide gas is produced. So now we can fill up the answers. State the final color of the cobalt 2 chloride paper in test 2, blue to pink. State what ion the observations in test 4 shows is not present, the nitrate ion. And for question F, identify the gas produced in test 5, the carbon dioxide gas. Identify the 3 ions in solid D. We have sodium ions because of the yellow flame. We have Fe2 plus because of the green precipitate. We have carbonate ions because of the carbon dioxide gas produced when it reacts with acid. For the last question, first of all, when excess dilute sulfuric acid is added to solid zinc, hydrogen gas and aqueous zinc sulfate are made. Plan an experiment to show that copper is a catalyst for this reaction. Your plan should include how the results of the experiment will show that copper is a catalyst for this reaction. You are provided with zinc powder, dilute sulfuric acid, copper powder, and common laboratory apparatus. So for the experiment planning, first of all, you need to prepare a conical flask with 25 cm³, 0.1 mol per dm³ of sulfuric acid. For the second step, you can connect the conical flask to a gas range. For the third step, you can prepare a 0.5 gram of zinc powder, and you can prepare 0.5 gram of copper powder as well. And you transfer 0.5 gram of copper powder to the conical flask. After that, you transfer 0.5 gram of zinc powder to the conical flask, and immediately you place stopper or bung. After that, you record the time taken to collect the cm³ of hydrogen gas. You can calculate the rate of reaction by using this formula, the cm³ of hydrogen gas over the time taken. After that, you can filter the resulting solution and you collect copper powder. You can dry the copper powder in the oven and you weigh the copper powder. If let's say copper is a catalyst, the mass of copper powder should remain unchanged. And for the next step, you can repeat the experiment without copper powder and you can compare the rate of the reactions with and without copper powder. Because if let's say copper powder is a catalyst, then the rate of reaction should be faster compared to the experiment without copper powder. So this is the end of the paper. I hope you enjoy our video. Please click the like and subscribe button for more exam paper explanation video. See you next time.